find the first difference. And this is negative 1.8. Negative 1.3. Negative 0.9. And negative 0.6. Okay, so in this case, if I'm looking at the first difference, I can tell that it is not linear because my first difference is not constant, right? So this is where I need to go on and do the second difference, okay? So if we do the second difference, we're going to get 0.2. 0.5, 0.4, and then 0.2. What can you tell me about this one? Not constant either, right? So we're going to say this one not constant, therefore not linear. Not constant, not quadratic, and then we're going to have to go back to our original y values, and then we're going to have to do the first ratio, okay? So remember that when you're doing the ratio, you're going to go back to the y, and you're going to do y2 divided by y1, right? So 7 divided by 9. 0.8. 5 divided by 7, or 5.2 divided by 7. 0.7. Okay. 3. Then I have 3.9 divided by 5.2. Is it about 0.8? Seven five rounds to 8, right? Okay. Remember I said yesterday, sometimes you're going to see that your numbers are not 100% the same, but they're close, okay? Because remember that with the exponential and with collecting data, your points are going to be a little bit off, right? You're not going to have 100% match with your line of best fit or your curve of best fit. So as long as it's close enough, as long as you see a consistency, then you can say it is constant, okay? So in this case, what do you see about the first ratio? It's somewhat constant, right? It's somewhat the same, except like 0.7, 0.8. For which one? For all of them? Okay. Yeah, so it's around the 0.7 something, right? It's around the 0.7 something. Okay? So if I'm looking at this, I'm going to say it's somewhat constant, and basically picking, if I want to pick out of these three, if I want to pick a regression, it's going to be an exponential. Okay? Because this is my best bet. I want this, you're gonna do this. Even if you don't think that's right. But then, if the question asks you to pick, then I'll teach you how to choose. Okay? All right. So in a science experiment, students punched a hole near the bottom of a 2-liter pop bottle. They filled the bottle with water and measured how the water level changes over time. The results are shown in the table below. So what do we have here? What's the case? Yes, right? Because what you have a water bottle. There's a hole near the bottom of the water bottle, and then the water is leaking, and they're showing you the volume of water that's still left in the bottle. Okay? So what they want you to do here, you're going to use graphing technology to perform linear, quadratic, and exponential regression on the data. So in this case, they're telling you they want all three of them, and then later you're going to pick which one is the best. So what I want you to do right now is I want you to either get to a computer or open your laptop or whatever technology you have, and I want you to graph this and do all three kinds of graphs. Make sure that you make all three kinds of graphs, right? Because we're going to compare all three of them. Okay, I want to see all three regressions next to each other.